Have you ever wondered what it would be like to traverse the intriguing, barren landscape of Mars? Well, for decades mankind has been attempting to unravel the mysteries of the Red Planet, not in person, but through the eyes of our robotic emissaries, the Mars Rovers. These remarkable machines are the result of years of technological evolution, each generation more advanced than the last, meticulously designed to brave the harsh Martian conditions. They serve a grand purpose: to explore the alien terrains of Mars, to conduct groundbreaking scientific research, and to transmit invaluable data back to our home planet. With each wheel rotation, they inch forward on Mars, paving the way for a future where humans may one day set foot. They are our pioneers on a new frontier, leading us into an era of interplanetary exploration. Now you must be wondering, how do these rovers pull off such a monumental task? Mars rovers are marvels of modern engineering, built to endure and explore the harsh Martian environment. These robotic vehicles are designed with precision, equipped with the latest technology to traverse the rocky terrain and conduct scientific research on the Red Planet. Let's start with their mobility. Mars rovers, like the well-known Spirit and Opportunity, are fitted with a six-wheel drive system. This advanced wheel system allows them to navigate over uneven terrains, climb steep hills, and even roll over rocks up to twice their wheel height. Each wheel has its independent drive motor, giving rovers flexibility and control over their movements across Mars' challenging landscape. Next, let's talk about their power source. Mars rovers are solar-powered, harnessing the sun's energy to charge their batteries. These solar panels are so efficient that they can keep the rovers running for months and even years on end. The sun's energy is converted into electricity, which powers everything from the rover's computers and heaters to their scientific instruments and wheels. This solar power system enables rovers to operate autonomously, far from the reach of conventional power sources. Communication is another vital aspect of Mars rovers. They communicate with Earth via orbiting satellites, forming a sophisticated relay network. The rovers transmit data and receive commands through this network, keeping scientists back home updated with fresh information about the Martian surface. This communication system is so advanced that it even allows rovers to send back stunning images and crucial scientific data from Mars to Earth, a staggering 140 million miles away. These elements, mobility, power, and communication, work together seamlessly, enabling Mars rovers to explore the Red Planet autonomously. They can drive across the Martian terrain, conduct scientific experiments, and send valuable data back to Earth, all while withstanding the harsh Martian environment. But rovers are not just about mobility and autonomy, they are scientific powerhouses. Each Mars rover is a mobile laboratory, equipped with a suite of scientific instruments designed to analyze the Red Planet. These instruments are the eyes, ears, and touch of our rovers, each playing a distinct role in the exploration of Mars. First, let's talk about the cameras. Navigation cameras, or navcams as they're often called, are the rover's eyes. They capture high-resolution images of the Martian landscape, helping the rover navigate and avoid obstacles. On the other hand, mass cameras, or mass cams, provide panoramic views of Mars, allowing scientists to study its geological features and assess potential areas for further investigation. Next up, we have the spectrometers. The Alpha Particle X-ray spectrometer, or APXS, is like the rover's taste buds. It analyzes the elemental composition of Martian rocks and soil by bombarding them with alpha particles and X-rays. The chemistry and camera, or ChemCam, uses a laser to vaporize small portions of rock, analyzing the resulting plasma to determine the rock's composition. It's the rover's way of getting a taste of Mars. Now let's not forget about the drills and analysis tools. The rock abrasion tool, or RAT, is essentially the rover's hands. It grinds away the outer layers of rocks, exposing fresh surfaces for analysis. The sample analysis at Mars, or SAM, is a suite of instruments that analyzes samples of Martian soil and atmosphere. It's like the rover's nose, sniffing out organic compounds and other indicators of past or present life. Finally, we have the environmental sensors, the rover's skin, if you will. Atmospheric sensors measure temperature, pressure, and humidity, providing valuable data on Mars's climate and weather patterns. Meanwhile, radiation detectors monitor levels of cosmic and solar radiation on the Martian surface, helping to assess potential hazards for future human missions. These instruments provide critical data, but how does a typical day in the life of a Mars rover look like? Well, let's find out in the next scene. Each day on Mars is a new opportunity for discovery. For a Mars rover, the day begins with meticulous planning by mission controllers on Earth. They strategize the rover's activities for the Sol, a Martian day, selecting scientific targets, plotting driving routes, and deciding on instrument deployments. Once the plan is set, it's time for action. The rover autonomously executes the planned activities, traversing the rough Martian terrain with its multi-wheel drive system. It uses onboard navigation and hazard avoidance systems to steer clear of obstacles and reach its targets. As the rover carries out its tasks, it collects a treasure trove of data. This could be high-resolution images, elemental readings from rocks and soil, or atmospheric measurements. This wealth of information is then transmitted back to Earth. Back home, scientists meticulously analyze the data, interpreting geological formations, chemical compositions, and other key findings. From these data, scientists can unravel the secrets of Mars, its history, and potential habitability. Mars rovers are more than just machines, they are pioneers paving the way for future exploration. These robotic marvels have transformed our understanding of the Red Planet, shedding light on its geological history, atmospheric conditions, and potential for harboring life. Their tireless exploration has uncovered evidence of ancient water bodies, suggesting that Mars may have once been a hospitable environment for life as we know it. The rovers have also opened up new frontiers in technology, with each generation boasting advancements in mobility, power, communication, and scientific instrumentation. Even as these rovers brave the harsh Martian terrain, they continue to send back invaluable data, helping us piece together the puzzle that is Mars. Their legacy is one of curiosity, perseverance, and discovery, inspiring us to reach for the stars and beyond. As we continue to explore Mars, we are one step closer to answering the age-old question, are we alone in the universe?